Now there are 4 questions remaining, and some of them are really similar to the examination, like this one, about the diffraction. For this question, you see that there is a water tank with deep and shallow region. So we should be familiar with this deep and shallow because we have been doing this quite many times already. So for the deep region, it refers to the larger speed. And for the shallow region, it refers to a smaller speed, right? So according to this, we may answer the question. Name 2 wave phenomena may occur when you travel from P to Q. Hi, good morning. Isaiah King. Yeah, so the diffraction actually, because it passed through a barrier and also it changed in the medium. So that's why there are 2 phenomena. Yeah, perfectly correct. Diffraction and refraction. Diffraction means when the wave passes through a barrier, it will change direction. And the second one is refraction. It refers to the change of medium that may result in a change in speed of light, speed of wave, and also the change in wavelength. So you may notice on the diagram, it has a larger wavelength here, and it becomes a smaller wavelength. So we always have this relationship. The lambda ratio should be equal to the speed ratios. Okay, this is something you should be understand. So 2 marks. Name the phenomena. Okay, and part 2, the wave pattern when the straight wave generate in P like this, and then you see that the wavelength change. Compare the wavelength and the speed. So you may just say that in region P, it has larger lambda and larger speed compared with Q. Understand? Both of them would be changing like according to this. So very simple, and let's go on. So now, let me clear this. In fact, we did that before in the test. Similarly, now the diagram doesn't show you anything in between the boundary, okay? But you only see the resultant pattern. It looks like something like that, and you should suggest a method to show this pattern. And in fact, the answer should be just like putting an object here. Okay, you put an object here, the wave would bend at this boundary. So this is how the answer of this part B. And the question, is it okay? It's not difficult, right? Just like a very typical diffraction question. But the next one will be a bit difficult. Now, we have been doing some questions about the ST graph, but this graph showing the VT graph instead. VT graph instead. So for VT graph, we may do some revision first. Maybe I try to draw this diagram in the other page. It's something like this, right? And after that, it drops. And eventually, something like that, huh? My diagram may not be perfect, but I will try to make use of that to explain what's going on. This question is talking about a person in a rocket, or I forgot, is it rocket or something like this. He's being ejected from the seat for emergency. Then there will be a upthrust pushing the guy upward, and this is the VT graph of it. Now, so when we look at the VT graph, remember above the x-axis means it's the motion going upward, moving up. And for any region with the curve that is under the x-axis, you may say that it is moving down. Okay, so basically, you may see that there are circle segments. I will call this is number 1, number 2, and I will call this is number 3. In fact, at least we can tell what is happening in the number 1. It is a accelerating motion. The speed is increasing. So why the speed would be increased upward? The reason is we have something like an engine or propeller to push the air downward that would push the person upward. That's why when the fuel is still there, it's keep burning and push the person upward, you will see this curve upward. Okay, this is the first part. And up to this point, you may imagine the fuel is used up. No more fuel to support the person. And as the result, there will be a free falling. The speed would drop, or the speed would drop off for free falling. It's actually due to the parachute, isn't it? I will check from the question again. You may see that the speed is actually decreasing. Okay, it's decreasing. Right after a certain period, it comes to a point. The speed decreasing, but it's still going upward, remember, okay? It's still going upward. It may be due to the gravity only. I need to really check from the question. You just know that at this point, the field used up and the speed could not increase anymore. It will slow down. And until a point, remember this point is very important. It's in between going up and going down. That means there will be momentarily at rest. Momentarily at rest. So that means it is at the peak, maximum height. Maximum height. So at least you can identify what is going on from here at the first region and the second region, and also this point. Be careful, okay? So the part 3 I will explain later. So let's go back to the question. You have a rough idea on what is going on here. First, so next is, so let's go back here. Now let's read the question again. You see this curve. For the T equals 0, the rocket installed under the seats ejected. So that means there would be a supportive force from the burning fuels, accelerating upward. And after this point, it reached maximum height on which is its maximum height. Seats is detached. There is a parachute. After a while, or after a while means after a while up to this point, okay, it reached a maximum height. Can you get it? It will slow down gradually by the gravitational force, and then it would eventually come to a rest. So that is what the question is talking about. And after that, it will start going downward. It has acceleration at the beginning, but you see it's a curving upward. That means the slope would become smaller and smaller. Okay, the slope is getting smaller. Oops, what happened? The slope here is getting smaller. You may just imagine it's slowing down. It's originally gaining speed. It keeps gaining speed up to a certain level. This is the maximum speed it can have when it goes downward. The acceleration will gradually decrease, not the velocity. The acceleration is gradually decreased due to the slope. The slope are the acceleration of it, okay? Now, so it sounds so complicated, but let's go on to see what are the question asking. Some parts will be easy. Don't give up on any question like this. Now, there are A, B, C, D. First, let's have a look on A. Label in the graph which instant when the dummy reaches the maximum height. So it's always at that point, the point where the speed is 0. This is the point where it reaches the maximum height. Is it okay? Now, so remember this, whenever you see a VT graph, this point is momentary rest, it means it goes to the maximum point. Okay. So very easy. Second, find the maximum height above the ground. That means how far that passenger can reach. So that means you're looking for the distance or displacement. And then in a VT graph, the way you find that is by using the area. So this area distance, it goes upward, okay? Distance travel upward. So the answer is basically only finding the area of that. It's a triangle. So triangle area is equal to the base 5.5 times height 50 and then divide by 2. Okay, is equal to 137.5 meter. It will reach a height 137.5 meter upward. Okay. So this is the answer for the part B. Let me erase this first. Okay, part C. If the dummy is having a mass 80 kilograms, find the force exerted by the ejection seats on the dummy. Okay, in the phase 1. Now, phase 1, you don't need to bother about the phase 2 or any other time. You just look at the curve on the phase 1. This is the curve in the phase 1. Okay, this is starting point and the finishing point. From the graph, the only thing you can find is the acceleration. So you don't need to think that much. You may just find the acceleration first. Acceleration equal to the slope. Sometimes you have to be simple-minded. Like a question about VT graph, you may just find the slope and also find the area. So the slope is equal to 50 divided by 0.5, so which is 100. The acceleration is 100 upward. But the question was asking, what is the upward force, the force pushing the guy upward? Oh, let me go back to this. We're looking for the ejection, the force exerted by the ejection seats, okay? Now, in order to find that, we have to draw the free body diagram, okay? There are two forces acting on the dummy. The first force is the force from the ejection seats. I call it normal force, okay? And the second force is the weight. Some of you may just find the answer directly like, oh, F equal ma is wrong. If you find F equal ma, you may not get the correct answer. I forgot the mass of the person. The mass should be 80, okay, 80. So you can set the equation from there. The net force is equal to, it's going upward. That's why the net force is looking at this diagram to tell which is N minus W. Upward force minus downward force, it would be the net force. And this is equal to ma. Never put any force equal to ma directly. This ma is equal to the net force, and this net force is always obtained from the free body diagram. If you don't have the free body diagram, basically, most of the cases, it would be wrong, unless there's only one force acting on an object. Otherwise, you need to consider all the forces acting on it to get the net force equal to ma. So, since you're looking for this force, the normal force from the ejection seats, it would become the weight plus ma. And the weight is equal to 80 times 9.81 plus 80 times 100, right? So the answer would become around 880. Around, let me calculate the exact value. Okay, 880 times 9.81. Okay, this should be 8632 Newton. Okay. Now, I would suggest you to spend a little bit more time on this question, especially when it's talked about an object going up. Okay, it's the same with the question in the lift. There are two forces with a normal force and a weight. If it is accelerating upward, it has a meaning. That means the normal force is larger than W. We did a similar question yesterday, right? About the water rocket. The water rocket could accelerate upward at the beginning because this normal force is larger than the weight. That results in an upward acceleration. So this is the concept about the Newton's law. Huh? So this is part C. Okay, part C. It's a bit difficult for part C already, but later on, part D and would be even more difficult. Huh? So let's have a look on what is part D talking about. It's a 4-mark questions with a star, but this star is something for old syllabus. In the old syllabus, this star means 1 mark for communication. That means they would look at the passage you wrote would be clearly presenting your idea or not. If your writing is good enough, you will get that 1 mark. So in fact, if nowadays we have the same question, it will be only 3 marks because we don't include a communication marks anymore. So now what we're doing is considering the force acting on the dummy. So that is a hint. It's actually talking about net force or free body diagram. Every question related to force and motion, we should always consider net force and free body diagram and explain the motion of the dummy in the phase 2. Okay, after the parachute has been opened, the dummy accelerates downward at first, and then having uniform velocity motion. Okay, there are 2 parts. That means from this sentence, you should answer the question in 2 parts. The first part is accelerating downwards at the beginning, and later on, it comes at uniform velocity. So you need to answer this. All right, when there's a parachute, okay, on the dummy, when the parachute is open, how many forces is acting on this dummy? Again, is 1 force is the weight, the second force is the force from the air resistance on the parachute. Okay, first, why the dummy accelerate downward? It accelerate downward is for the weight larger than n. Do you agree? If it accelerates downward, it has to be the weight larger than the air resistance. So at the beginning, it travels slower, at slower speed. The normal force or the air resistance would be also smaller. So what you can tell is n is depends on speed, or increases with speed, it would be better. Just like when you run fast, you feel the wind blowing on your face. That would be, it has a meaning like it has a larger air resistance. When object is not moving, the air resistance should be smaller. So for the first part, let me just imagine when the speed is small, slow, the weight is larger than n, so that the net force is equal to W minus N equal ma. It accelerates downwards. I want to highlight again, answer the questions by using Newton's second law. Be able to write this relationship. This one, this relationship. Let me put a tangle here. This one. You use this sentence to answer the question. Okay, later on, why it would become uniform velocity? So for uniform velocity, in fact, it's similar for part 2. when n become same value, because it's increasing, right, with W. So the net force would become W minus N equal to 0. Now, so when the two forces become the same, that would become uniform velocity, okay? It drops with uniform velocity. So that is the answer for question 10, part D. Learn from the skills, what kind of sentences we should be able to write. Okay. In the first part, you are talking about Newton's second law, FMA. But when the net force is 0, it's referring to the Newton's first law. The net force is 0, and it moves in uniform velocity or stationary, right? So it's important for us to read the question carefully and chop them into different regions, different parts. Like in this question, you mentioned uniform accelerates downwards. So that means net force is ma. And the second part is uniform velocity. That means net force is 0. You just write these sentences and you get marks if you understand what is going on, right? So that's the end for the question 10. A difficult question, challenging, but the skill behind is not really difficult. Okay, next one is a question, again, quite similar to the examination. I would say similar, not exactly the same. What is happening is there is a parcel is being put on the conveyor belt in the factory. It means that you have to move an object from point P to point S. Surely it can't move too fast because it's just like transporting an object from point P to S. Originally, P is at rest, so that's why you need to provide a force to accelerate that until it attains a certain speed. And we could go in uniform velocity motion until a point R, according to this. Since you want to move it to S, point S, it will slow down gradually from R to S. So in these three parts, what we can say is, for the PQ, A is larger than 0. For the second part, A is 0, right? And third part, A should be negative. Sorry. A should be smaller than 0, so that it will slow down, okay? So you draw a free-body diagram to show all the forces acting on the parcel, on the space provided below. And you need to name the forces. Now you have to name all the forces. Wait, someone is sending a message to me. Oh, it's already. Now, so for the free-body diagram, you will just have a look on the parcel. For this parcel, there's some forces acting on it, including the first one is the weight. The second one is it is in touch with the belt, so that's why it would be a normal force upward. And the third one is it moves forward. So who provides the force forward? There's no pushing force, it's only in contact with the belt, so that's why it's the friction. The friction pushing it forward. Okay, now the question is asking from P to Q. So this is the free-body diagram we are supposed to be able to draw. But since the question asks you to name the forces, you can't just put the symbol. So please, when you draw the free-body diagram answering question, you must write the full name of it. So let's say this is the free-body diagram at P. The question can also ask you to draw the free-body diagram at Q. At Q, since it is moving with uniform velocity, so that means there's no friction. friction equal to 0 at that part. It just move together with same speed. Okay? And you can also draw the free body diagram at S. But this is not the question asking, but I try to like doing revision with also on this. Vertically, the weight and the normal force wouldn't change, but now from point R to point S, it is decelerating. So that's why it's decelerating. So that's why the friction would become in the opposite direction. Okay. Rohan, what happened? I admitted Rohan. Let's see who's that. Oh, it's backward. Surely the question only asks for the P. Only asks for P, but I also draw the Q and S. The Q, sorry, yeah, I mean Q to R. Sorry, Q to R. See, fooling around, Mr. Lau. It's Q to R, and this is R to S. It's not like this. This one is P to Q. Okay, any question?
No, sir.
Good. Is Rohan here? Hello?
He left, sir.
He left. Oh, I want to ask him something originally. Let me call him later. Okay, so that's the question part A1, okay, free body diagram. Secondly, find the net force acting on the parcel. Now, this is still on the part P to Q, okay? Sorry, still P to Q. So what information we got from the question? 5 meters, 2 seconds. 5 meters, 2 seconds. Let me write down. What happened? Displacement is 5 meters. Time is 2 seconds. And originally, the initial speed is 0. So we know that the net force is equal to friction according to the free body diagram we have. So that friction is equal to MA. We're looking for this. But we don't have the value of the A yet. We may calculate that from this equation. We got this equation. S, T, U, and we find A. This is the equation we did. So we put the value 5 equal to 0 times 2, and then half times A times T is 2 squared. Oh, Johnny requests to join our lesson, but I won't let Johnny come.
Why, sir? Everyone have the equal opportunity to learn.
Johnny is not using his real name. Okay, 2 squared is 4. So you may just cancel it. Okay, so A is equal to 5 divided by 2, which is 2.5. Now, so once you got this acceleration, you may put it back to the MA. So the mass of the parcel is equal to, let me check, 10 meters. Oh, sorry, 10 kilogram, 10. So it is 10 times 2.5, which is equal to 25 Newton. Okay, so force acting on the object is 25 Newton. Any question?
This
okay,
one, okay.
That's okay,
This
right?
one, okay.
If okay, this one okay, right? So let's go on. There are 2 parts actually. If you find this one first, you get some marks, and after that, you do this. Okay, step by step. Okay, let's go on to the next part. Oh, you draw the variation of friction in this diagram, the force acting on that. So we did already 25. And then, just like according to the question, can you let Johnny in? I can't. The second part is just simply 0. According to the question says that it's moving uniformly, right? But after that, it will slow down. But you can imagine it takes longer time to slow down. So that means longer distance to slow down. That means what you need is smaller value. Okay, you need smaller value for that. And at the same time, I want to remind you one thing. There's the meaning of this area. Now, this is no longer displacement. Can anyone tell me what is the meaning of this area? Just try, don't be shy.
Negative force.
Negative force? No, this is not the. Now, this value is the negative force. It's going in, the force is in opposite direction, is correct, but what's the meaning of this area?
It's below 25.
Yeah, it's more than 25.
It's equal to that area of the whatever the area is.
Yeah, both areas are the same, good. But what's the meaning of this area?
Why don't you tell us?
Well, louder.
Why don't you tell us if you know so much?
Or you just want to tell me answer, let's see whether you know that. Now, let's look at this. When you look for the area of a graph, basically, you just consider the product of these two. If you use force times a certain distance traveled, what's the meaning of that? You have 25 Newton and it traveled for a certain distance. So that means it's F times S, right? It's actually work done. Now, at the beginning, you provide energy to the object so that it gains kinetic energy, so that it moves with a certain speed. So this is what is happening at the first area. Second part, there's no work done, so it will just keep its KE. But the last part, you're having a force opposite to the motion, a negative force. So you're taking away the energy from the object so that it will slow down. So that's why these two areas are the work done from the friction. At the first part, it provides energy. And the second part, it takes away the energy. So at the end, it will become stationary. So that means the area here should be the same. And that's why we know that this value should be smaller. Okay? So this is the part B. I think that is the end of this part, but I want to elaborate a little bit more. Now for this question, we can also ask how to draw the VT graph. Now let's say this is P, Q, R, S. So what you can do on drawing this graph? What do you think? No one trying? So silent.
Yes, sir. What is your question? I was not paying attention.
Okay. Now my question is, if the question asks you to draw the VT graph, in this case, now you are given the information from the question here. A Rohan comes again. Is it the real Rohan or fake Rohan?
Just let him in.
I'm letting him in. Let's try first. Let me talk to Rohan. Rohan, are you here?
Hello, sir.
Wait, I want to ask you a question. Is your building included in the building, like you have to do the test compulsory?
In my building, sir.
Yes. Is it?
Rohan,
No, sir. No.
No. Okay. Just worry if you can come back to the school tomorrow. If you don't, you're not included. That means you can come back to the school to take exam normally. All right.
All right. Yes, sir.
So keep me updated if you got any problem. Okay, now
Okay.
someone answer me the question. P to Q, V increasing gradually, yes, stable, or Q to R and R to S decrease to 0. Very good, perfectly correct. So what you can do is to draw the lines. Oh, sorry, what I'm doing, I'm using arrow. I'm using lines like this. Okay, and then horizontally, uniform velocity, and then at the end. Okay, now so that is the graph you should be able to draw or to be able to read. So what's happening on the force? In fact, first region, there's a positive work done. And this work done will provide the energy into change in KE. The change in KE is increasing in this region, right? So you can also calculate the KE by looking for this half mv squared. Okay, you have mass, you have velocity, so that you can find the KE gain. And secondly is, the second part I use red pen. There's no work done. Work done equals 0 in this part, this region. So the KE will remain the same. The change in KE is 0. And for the third part I use black color. Oops. This region, the work done would be negative. Is equal to the change in KE, but this change in KE is negative, okay? Negative work done from the friction. So you can calculate anything the question asked, basically. For any motion, you can understand that by force and motion. Or you may just interpret that by using work done and change in KE, change in PE. Is it okay? So bear in mind, so question can be asked in different direction. So this is the end of the question 11. Okay, last question. Last question is lens question. For some people, they mistake a rear mirror. To stick something to the rear mirror of the car is actually a lens. This one would enable them to have a larger view from through these small parts of the lens. And the question is asking something about this. So let's see. Do you understand what's going on? Okay, the rear window, he sticks something on it, and that is a lens. That lens will enable him to see a larger view like this. So this is the image he saw through this lens. So what kind of the lens it should be, and explain your answer. As I mentioned before, whenever you see an image, you try to label its nature first.
Okay.
So the nature is upright and diminished. And since it's upright, it should be also virtual. But it doesn't matter. Usually we only need these two to tell what lens it is. When it's upright and diminished, it has to be concave lens. And the reason you just say the nature of image is, yes, it's very, because this question may be a little bit old, 2004 or 2005, I forgot.
Old like Mr. Lau.
Just a little bit elder than you, or you're elder than them. So yeah, not DSE, is CEE questions.
Oh, sir, it was your time's public examination, right?
Oh no, it's 10 years after my time.
Oh, you're way old.
Yeah, so old. I am
Sir,
elder
who
than
live
you.
in the
So
Earth? Are you
Earth? No, Earth has like 4.6 billion years.
Oh, you're 5 billion years old. Okay.
Now, so this is the answer. Concave lens, the reason is the nature of the lens told you, okay, upright and diminished. For any other possibility, not the same with that, they're all convex, okay? Only one possibility for concave is upright and diminished. For other cases, they're all convex. It's concave. Did I say concave, convex? Okay, concave and convex. So bear in mind, you need to study that, okay? Next question. You have to draw the ray diagram, okay, in this graph paper. So the question gives you the scale already. For like this scale is 10 cm. What you have is 60 centimeter in front of the lens, and the focal length is given 30 cm. So you have to draw. In my pen doesn't work. What happened? Here. Okay. Now, what you need to draw is to locate the lens first, because the lens is 60 centimeter away from the lens. So you may just draw 20, 40, 60. So the lens is somewhere here. Okay, draw the lens first. And surely you should also draw the principal axis. Yeah, 少少歪咗唔緊要啦。And the focal length is 30 centimeter, so which is here. This is the focal length, okay? Then what should you do? Again, two light rays. Central point goes straight. What I'm doing? I'm using straight line. Come on. Central point goes straight. Okay, and isn't the arrow switch? What do you mean? The arrow. I'll show you the image arrow, and then you also need to draw the horizontal line. Yeah, correct. It's a concave lens. The arrow should be pointing in the other way. Okay, let me change it first. Thank you for reminding. I see Mr. also absent-minded. Let's draw again. Okay, it's a concave lens, that's right. Now, parallel light ray will go to focus, so you may also draw this line. Now, but the focal length should be at this point, in fact, since it is a concave lens, so the light ray should be coming from this point to this point. Okay, but remember, behind the lens, you should use dotted line. And the image should be somewhere here. It's okay? This is this arrow is the image. So it's a bit smaller than the original one. So what is, you find that already, isn't it? So this is the radar when you find the image. Do not forget also the arrows. Okay, this is the image. Any question for this? So don't forget the focus is on the left-hand side for concave lens. It's a common mistake. Okay, next. Stage one advantage of this lens. So why are we putting this lens? You have a big rear window. You suppose no need to put anything, so you can still see everything from behind, right? So why are we putting that? Wider view, exactly, correct. So you can see a bigger, wider view. So that's the reason. It's similar to the mirror in the supermarket, 7-Eleven. So there's a curved mirror, so it shows a bigger view. wider view for the driver or for the people, so for the shopkeeper.
Sir, why don't we learn about concave and convex mirrors now?
We don't have it right now because it's being cut from syllabus. I don't know why. It's actually very easy, similar to the lens.
Where can you teach?
If you want, you can come to me. I teach you.
After this lesson, you teach.
Yeah, sure. After exam, you may come to me. Is it a must to, let me check. Is it a must to have a mirror to be concave lens? To be a concave mirror and lens are different. Do you understand what I mean? Is it a must? If convex, yeah. If you have a convex lens, everything will be upside down. We can only have an upright image when we put the lens really close to the object for the convex lens. So if you want a wider view, the only thing you can do is by the concave lens. So short-sighted people will have a wider view. The reason is they are wearing the concave lens. So that's the end for the vision exercise. You have like 20 hours for your revision, and surely you need to spend some time to sleep. Just try your best and revise everything. Okay, I already give you some hints, big hints, time by time. So yeah, let's see how you can achieve, how much you can achieve in this TED examination. All right, any question? If you have any question, just message me anytime, okay? Yeah, but don't ask me to teach everything once again. You know, every year before the exam, some people will say, I didn't listen carefully during the lesson. Can you teach me the whole book once again? How can I teach the whole book within few hours? It's not possible, right? Okay, don't cry. Come on, cheer up, boys and girls. Yeah, it's always, this study is always difficult. No one tells you study is easy, right? So many people studying at the same time. So I think the only thing is to pay more effort than the others. So you will have a better chance to do better than the others. Okay? Okay, that's the end. So see you guys. I will put this video online later. Bye-bye.
Sir.
Yeah, question. Yes.
Yeah, I need to tell you something later.
Later.
Can you stay here?
Okay. So let's wait for the other left. What is your rank when you are in secondary school back then? When I was in
Number 1.
Form 5, I think I'm around the 10 to 15 in the class. And yeah, in the Form 6 and 7, I become the top 5.
So how about physics? Number 1.
Physics, not number 1. I'm just like become the first 5. I'm good in math and physics, but not really good in the languages.
Me too, sir.
My language was really bad in Form 5, but I spent a lot of time. So in Form 7, I can like getting an average level. Yeah, so you may leave the classroom. Can you still speak Mandarin? 我应该不太会说普通话，现在应该跟普通的人沟通的时候，应该他们听得懂我说什么。Okay, bye bye. Who else here? Isaiah, are you here? Junior, are you still here? Pedro?
Sir, I typed in the chat bar.
Oh yeah. What is full mark for exam? Full mark. That would be once again, 30 questions, MC questions. Let me write down here. 30 MC questions, and it would take 35%. 80 marks for long questions. And it would take 65%. That is. Okay? This is how the distribution of the scores. Bye-bye.
Bye, sir.
So what do you want to say?
Sir.
Yes.
Rohan.
Sorry, louder. I can't hear you.
I don't
yes.
think you should trust Rohan. Rohan, you should
做咩啊？
trust him.
Sir,
Huh?
the building thing.
Sure, I think his building is in the name, in the list. Rohan's.
Really?
Yeah, you should check once.
Okay, I will check later.
Yeah, because I love my life.
Don't worry. You have safety measures, and you're not in the same classroom with him, right? What exam do you have tomorrow?
English and physics.
English and physics.
Oh,
Yeah.
is this so far away from Rohan? No, and try not to like having this. I'm not saying discrimination or too much worry. So many people on the street. If you go out street, they may be living in those buildings, right?
Kill him.
You have actually tried to reach the people living in those buildings, but you can imagine it's difficult for us to reach 1,000 and something students. For those we know, we try to call them already. Just like now, I try to ask him also.
Sure, kill Rohan.
Huh?
Kill Rohan.
做咩啊？
Kill Rohan 啊，打死佢。
點解啊？Rohan so good boy. Huh?
See you.
Okay. See you. Bye bye.
Bye, sir.
Bye, sir.
Bye bye.
Sir, you'll upload the video later on, right?
Yes, I will put a video later.
Okay, sir.
Bye.
Thank you.